Hello everyone. In this video, we will introduce the notion of independent events. This is a very important notion and you will see later that it implies good thing about the intersection and so on. So we will use this notion over and over again. Let's start with the definition. Assume that we have two events from the same sample space. Well, then we can find probability of E. Yes, that's an event. We can find probability of that. But we can also look for probability of E knowing that F happened. So this is not just probability of E, it is probability of E with the knowledge that F happened already. Okay? We have seen that these two numbers don't need to be the same. In other words, if you get extra piece of information, it may change the probability of an event, yes? But if it happens that these two are equal, so if that is equal to probability of E knowing F, then we say E and F are independent events. In other words, two events are called independent if knowledge of one happened does not change the probability of the other one. So the knowledge of F already happened didn't change the probability. The probability of E is still the same thing. A good examples of these events are when you have a coin or you have a die and you roll it twice. Any event related to the first toss is independent of any other event related to the second toss. So this is a good example to keep in mind because it's just intuitively, yes? If you see a coin, you toss a coin, it comes head, it won't change the probability that the next time you toss the coin, the probability of getting head or tail doesn't change. So there will be, they are independent. So any event for the first toss of a coin is independent of any event in the second toss. And rolling a die is the same thing. The number that comes up first time won't change the probability of getting the other one. So that's why basically these are some good devices to generate random quantities. Okay, that example just was based on intuition, yes? It cannot change the result of the second toss, knowing what happened in the first toss. But sometimes you have to do a little bit of work. So here I want to show you how to check two events are independent or not by, well, intuitively you cannot do that, but you have to do some work here. So here you roll a die and consider the event that the number is odd, and the other event is this is the number is bigger than. So here these are the number is bigger than 3. Actually, I can list the quantities of, or the elements of, these two events. For example, for the odd ones, okay, I know that it must be 1, 3, or 5. For the bigger than 3, it must be 4, 5, and 6. Now, probability of E is you count how many elements E has divided by the total number of elements there. While there are 6 possibilities, only 3 of them are odd, so the chance that we get an odd number is half. Makes sense, yes? But when you're trying to find probability of an odd number, knowing that the number is bigger than 3, you see there is only one number in F which is odd. So here, remember that we have done this work a lot, so that's enough to do this computation. Here, E intersect F, or the elements of F which are odd, there's only one, that's 5. So in this case, this will be 1 over, there are only 3 elements in F. You see that the chance that I get an odd number decreases when I know that the number was bigger than 4. So these two are not equal. That means that E and F are dependent. And that's how you check. So you find probability of A, probability of F, and see if they are equal or not. Let's see another example. A card drawn from the card from a standard deck. So E is a face card, comes up. And F is a red card. Yes. Now, I want to find what is probability of E. Okay, there are 3 faces for each suite. There are 4 suites, so there will be 12 faces in total, and there are 52 cards. You simplify or divide both by 4. This will give me 3 over 13. How about probability of E knowing F? Okay, so here, how many red cards we have? Well, there are hearts and diamonds. Together, they give me 26. How many of these guys are faces? Well, there are 3 faces for heart, 3 for diamond. In total, there will be 6. And if you simplify or divide by 2, you get 3 over 13. Oh, knowing F didn't change the probability of E. So that means that E and F are independent events. And that's how we define independent events. And you will see later that this property is very important. It's going to play a very important role in our work.